Hi students, I am Nimisha and I'll be teaching you your next chapter, polynomials. So what is a polynomial? A polynomial is any expression, meaning you take few things and put it together and you put few variables and constants and coefficients, you mix all that and put it, you get an expression. An expression is made of something called terms. Such a thing is called a polynomial, but there we have a few specific details. Meaning what? A polynomial is written as this: a0 plus a1x1 plus a2x square plus an1 an minus 1 to the power of x minus n minus 1. You don't have to by heart this, but what does this expression exactly tell you? See, all the x's are variables. All the x's are variables. These an minus 1, a2, a1, a0 are all numbers, constants, coefficients. They are called the coefficients of x. Here there is no x here. Why? But can I write this as 1? Yes. So it's a0 into x power 0. X power 0 is nothing but 1. Anything raised to the power of 0 is 1 due to the law of exponents. This, because x is missing here, this is called a constant term or a term independent of x. Each of these are called terms. So if I put, let's say x is equal to 5, then we don't know what's the value of n here. Let's say n is 7, then it becomes 5 power 7, 5 power 6, 5 power 5, etc., 5 power 2, 5 power 1, and you get some value. So basically what is happening in a polynomial? It's an expression made of a single variable. So we will call this as p of x, polynomial of variable x. It is a function. This is not multiplication. This is not p into x. This p of x is equivalent to this big expression. Meaning, if you put some value of x inside this, you will get another result. How do you get that result? When you put p of 5, that means wherever there is x, put 5. Put 5. You will see many examples where I will explain this again in detail, but I hope you're clear about what is a polynomial until now. What are the important things that we need to know here is x. All the x's are called variables and all the a's are called, the a1, a2, a3 are all up to an are all called coefficients. This will be coefficient of x square, this will be coefficient of x, like that. Okay, these powers of x, can you see, it has to be a whole number only. The power of x, the n, has to be a whole number. That means this power of x has to be an whole number only. Why? You can, if you have root x, is this a polynomial? If I have p of x is equal to root x, is this a polynomial? No. Why? Because this is nothing but x power half. Half is not a whole number. Can I have p of x is equal to 7x? Yes, you can, because 7 is a number, x is x power 1. This is one term, it's made up of one term. So you're stopping right here. See, you can stop here, you can stop here, you can stop here, you can go up to how many ever you want, how many ever x powers you want. So 7x valid. You can have p of x is equal to 7x cube plus 3, also valid. Can I have negative power? This is not valid. Can I have negative power? X power minus 3. No. Can I have 1 by x square plus 2? No. Your variable should not be in the denominator. Negative power is not allowed. It's only whole number. So negative power is also not allowed. So until here you have understood what we mean by polynomial. The next very important term that you will learn in this chapter is called the degree of the polynomial. Degree of the polynomial. What is the degree of the polynomial? It is nothing but the highest power of the variable in the expression. For example, if I have p of x is equal to 3x square plus 7x plus x cube, what is the power of x here? 2. What's the power of x here? 1. What's the power of x here? 3. What's the highest power of x in the whole expression? 3. So the degree of this polynomial is 3. Understood the meaning of degree? So now what are the different polynomials that we have? Let's see. Depending on the degree of the polynomial, you have a few names given to the polynomials. If the degree is 1, then the polynomial is called a linear polynomial. For example, if degree is 1, meaning, see, in this expression, highest power of x should be 1. That means x square and x cube and etc. are not there. Only this is possible. So instead of saying a1 and a0, I'll use a and b. Ax plus b. So a linear polynomial, the general notation of a linear polynomial is ax plus b. Okay? Examples: 7x plus 3, minus 7x minus 0.5. Negatives allowed, root is allowed, the numbers can be anything. Next, what if the constant term is missing? No problem. 7x also allowed. What if this term is missing, the 3 is missing? 3 is missing, no problem. But what if the x term is only missing? You know, this is 0x plus 3. Not allowed. Why? Linear polynomial, degree is 1. Degree here is x power 1, here it's x power 0. 1 and 0, who's higher? 1. Degree of the polynomial is 1. This term has to be there. If you make the first term 0, then the degree x, that x power 1 is not there. Then it's no longer linear polynomial. A linear polynomial tells you degree should be 1. Is this 1? No. Degree is not 1 here. Degree is 0. It's not there. Can degree be 0? Yes, degree can be 0. If degree is 0, then it's called a constant polynomial. Then it's called a constant polynomial. For example, the polynomial p of x is just made of some number k. Example, you can say just minus root 3, 7 by 2, 5. That means, see, in a constant polynomial, p of x is equal to 5. It's constant. The polynomial is always constant. If I put x equals 1 also, I'll get 5 only. If I put 2 also, I will get 5 only. But here, if I have this 7x plus 3, this is not a constant polynomial. P of 1, 7 into 1 plus 3, 10. P of 2, 7 into 2 plus 3, 14 plus 3, 17. See, the polynomial expression, the value is changing. You put 1, you got 10. You put 2, you got 17. It's a function. You are putting some number inside this x. Inside p, it's like a machine. There's some input, there's some process happening. This is the process. And it finally gives you a result. So I hope you understood why I call polynomial a function. Okay, coming back to these examples, what did we realize here? A cannot be 0. A cannot be 0. Now, next one. If the degree is 2, B can be 0 there, no problem. See here, B is 0 here. Okay, if the degree is 2, then such a polynomial is called a quadratic polynomial. This is represented as ax square plus bx plus c. This is the expression is ax square plus bx plus c. Example 7x square plus 5x plus 3. Valid. Can I remove the last term? Yes, you can. 7x square plus 5x. Can I remove the middle term only? 7x square plus 3. Remove the middle term, yes. Remove both these terms, also valid. But can I remove 7 itself? 0x square plus 5x plus 3. That means this is not there. Is this a quadratic polynomial? No. Why? If 0 is there, this goes away. If this goes away, now you have 5x plus 3. The power of x here is 1. The power of x here is 0. What's the highest power? 1. Degree is 1. Degree 1 is linear polynomial, not quadratic, which is why again this is not allowed, and therefore I can say A should never be 0. I hope you are understanding why we are saying A should not be 0. Next, if I have 3, then such a polynomial is called a cubic polynomial. Expression ax cube plus bx square plus cx plus d. Same method, you cannot have a0, because if I make a0, this will vanish. Then the expression becomes a quadratic polynomial, because the highest degree now becomes 2. So you have to be careful. You can have 8x cube minus 5. No problem if the middle terms vanish. No problem if d vanishes. No problem if all 3 vanish. But the x cube term has to be there. This term has to be there. If the degree of the polynomial is 4, then it is called a biquadratic polynomial. We have to know, we are going to solve till here, but it's possible to have higher, and after that you can have degree 5, 6, 7, anything. So all these are polynomials. Point to be noted that is A can never be 0. This is just a small recap of your previous class. In polynomials you learned that if a polynomial has one term, it's called monomial. If a polynomial has 2 terms, then it's called binomial. If it has 3 terms, trinomial, right? So what is this? Binomial. Why? Because there are 2 terms. What is this? Monomial. What about this? Monomial. What about this? Binomial. Let's say I have this trinomial, because there are 3 terms. So it's nothing to do with the degree, it's depending on the number of terms present. So here we have learned the names according to degrees. You need to know this as well as that. Okay, but we are focusing mainly on degrees in this chapter. So now let's assume we have a polynomial expression given here, x square plus 2x plus 1. What happens if I put x equals 0? If I put x equals 0, then p of 0 is 0 square plus 2 into 0. Wherever there is x, put 0 plus 1. 0 plus 0 plus 1, 1. That means the value of p of 0 is 1. That means in the polynomial, if you put x equals 0, you get 1. What if I put x equals 1 plus 1? P of 1 is equal to 1 square plus 2 into 1 plus 1. 1 plus 2 plus 1. 1 plus 2, 3. 3 plus 1, 4. What if I put x equals minus 1? P of minus 1 is minus 1 the whole square plus 2 into minus 1 plus 1. Minus 1 the whole square 1 plus 2 into minus 1 minus 2 plus 1. 1 minus 2 minus 1 plus 1 0. Pay attention here. When I put x equals minus 1, the value of my expression became 0. Such a number where you put the value and it becomes 0. So x equals minus 1. When you put the value of that variable and the expression becomes 0, such a number, here x equals minus 1, is known as a root of the polynomial. Or it's also known as the solution of the polynomial. Or it's also known as the 0 of the polynomial. Mainly in this textbook, you'll keep finding 0, 0, 0. All 3 mean the same. Is x equals 1 the 0 of a polynomial? No. Why? Because x equals 1 gives you, when you put x equals 1, do I get the polynomial expression value as 0? No. So x equals 1 is not a 0 of the polynomial, or not a root of the polynomial, or not a solution of the polynomial. So I hope you understood what this exactly means. So in this example we saw that we put x as minus 1 and we got 0. That means Minus 1 is called the 0 of the polynomial. So how do we define this? If you have a polynomial p of x, then this minus 1, let's say it's some number k. K is said to be a polynomial, say k is said to be a 0 of the polynomial when you put that k value inside x and you get 0. So p of k is 0. In the place of x you put that k, if you get 0. Here in the place of x you're putting that k. Who's the k here? Minus 1. Then k is called the 0 of the polynomial. How do we find the 0 of the polynomial? Many methods are there, but here let's take a simple example. If I tell you p of x is equal to x plus 3, you should do trial and error and somehow get the value of x such that if you put that number, this whole expression becomes 0. So as anyone can see, what should I put here to get 0? Minus 3. So p of minus 3 is minus 3 plus 3, 0. So what can I say? Minus 3 is a 0 of the polynomial. But now the question is, what do I do if it's complicated? For example, p of x is equal to 5x plus 7. What should I put in the place of x so this expression becomes 0? If you put 1, you'll get 12. Put minus 1, you'll get 2. You put 0, you'll get 7. You try different numbers, it's a little complicated. How do we do it? Simple. Take p of x as 0. You only make it as 0. 5x plus 7. Now solve for x. Minus 7 is equal to 5x. Minus 7 by 5 equals x. That means x equals minus 7 by 5 is a root of the polynomial. Let's verify and check. P of minus 7 by 5 is equal to 5 into minus 7 by 5 plus 7. 5 cancels. Minus 7 plus 7, 0. See? When you put minus 7 by 5, the expression became 0. So you got the steps. So below this, write down steps to find the 0 of a polynomial. Take p of x is equal to 0. Solve for x. That's all. Steps to find out 0 of a polynomial. Take p of x is equal to 0. Solve for x. We can't keep doing trial and error. It will take a lot of time. You can. It's not that it's not allowed, but we have to be quicker and smarter. So next example. P of x is equal to x square minus 5x plus 6. See, you have to find the value of x that makes the polynomial 0. That means find the zeros of the polynomial. What is the step I told you? Take p of x as 0. So first you take p of x as 0. So x square minus 5x plus 6 is equal to 0. How do we solve this? Solve for x. You've learned factorization in your lower classes. So I'm not going to repeat factorization here, but I'm sure a few of you will have doubts in factorization and not understand how to factorize. Please understand that in the chapter that says quadratic equations, I have done factorization in detail, step by step. So if anyone has doubts in factorization, please go to quadratic equation chapter. In that, there's a section where we have explained factorization in one full huge video with lot of examples. Go through factorization over there and then come back and try to solve it here. I repeat, it's in chapter 4, quadratic equations. Go through factorization over there and then come back over here. So now I am going to assume you know factorization. There's 1 here, 1 into 6, 6. Product is 6, sum is minus 5. You have to split 6 in such a way that you get 5. 3 and 2. Since there's a minus here, minus 3 minus 2 is minus 5 and minus 3 into minus 2 is 6. So I can write this as x square minus 3x minus 2x plus 6 is 0. Take x common, x minus 3, you should get the same x minus 3 here. So who's a filler term? Minus 2 is 0. So you get x minus 3 into x minus 2 as 0. So that means x minus 3 can be 0. Either this can be 0 or this can be 0 or both can be 0. So find the value x equals 3, x equals 2. Therefore the zeros of the polynomial are 3 and 2. Why did I take this example right now? Understand, what is the degree of this expression? 2. 2. How many zeros of the polynomial are there? 2. So write down a note. Whatever is the degree of the polynomial, that will be the total number of zeros of the polynomial. So a cubic polynomial, how many zeros will be possible? Cubic polynomial is x power 3. 3 is the degree. So there will be 3 possible zeros. If you solve, you will get 3 values of x. So now let us understand the geometric meaning or graphical meaning of polynomial. What does it mean graphically? How do I do it? See, in this question, p of x is equal to x square minus 5x plus 6 is given in the question. Correct? So what did we do here? When I put x equals 3, the 0 of the polynomial, my p of x will become 0. Do you agree? Yes. When I put x equals 2, my p of x will become 0. Do you agree? Yes. Let me call this p of x itself as y. Take p of x as y. So now you get 1 point 0, 3, 0. Write the x first and 2, 0. Draw it on the graph. See here, 3, 0 and 2, 0. 3, 0 here. 2, 0 here. So if you draw a graph, your polynomial will have a different curve. How it is curved, that's not your problem right now. You just need to understand the main point here. The point where the curve touches the x-axis, intersects the x-axis, that is depending on the zeros of the polynomial. It will intersect 2 times here because there are 2 possible zeros. So what can we say? The next note. So it had 2 zeros, so it intersected the x-axis at 2 points. So I can say in the same note, you say the degree of the polynomial also tells you how many times it will intersect. Number of intersections with x-axis. Number of intersections of curve. Number of intersections of the curve. Which curve? Polynomial curve with the x-axis. This is very important to understand why. I have explained it why. We will now go to see examples. So with the above note, we understood that degree of the polynomial gives you the number of zeros of the polynomial and also the number of intersections with the x-axis. So now look at the graphs given below. Each is the graph where y is equal to px. That means take your y-axis is the polynomial, like how we took it there. Where p of x is a polynomial. For each graph, find the number of zeros. You have just check intersection with x-axis. We don't care about intersection with y-axis. Just see intersection with x-axis. It is intersecting the x-axis only at 1 point. So that means degree is 1 and number of zeros are 1. So answer is 1. It is intersecting the x-axis as 1 point here and 1 point here, 2 points. So the number of zeros will be 2. Intersecting the x-axis as 1, 2 and 3. So the number of zeros will be 3. Continuing. How many intersections are there? See, there are many intersections. You should worry only about the intersection with x-axis. 1 intersection, so number of zeros 1. Again 1 intersection, number of zeros 1. 1, 2, 3, 4. 4 intersections with the x-axis, number of zeros 4. Let us begin with exercise 2.1. It's just very similar to the example 1 we did. The graphs of y equals p of x are given below. For some polynomial p of x, find the number of zeros of p of x in each case. Is this intersecting with your x-axis anywhere? No. So is there any zero? No. So there are no zeros of the polynomial. The number of zeros of the polynomial is 0. Here, it's intersecting x-axis at 1 point, so 1. It is intersecting x-axis 1, 2, 3. 3. So now it's intersecting here at 2 points, so number of zeros 2. 1, 2, 3, 4. 4. 1, 2, 3. 3. This is just a little higher, an extra point for you guys to understand. It's not in your textbook, but it's good to understand this. Let's say instead of p of x I had given p of y. P P of y is equal to y square plus 3y plus 2. Many times what happens, we take this y in the y-axis. P of y will now become x. That means when you put different values of y, your x is becoming 0. So if you have an expression of P of y and you have a graph, you are now not supposed to see intersection with x-axis. You're supposed to see intersection with y-axis. If you have P of y, please look at intersection with y-axis. If you have P of x, look at intersection with x-axis.